Okay, question 7, we're on about electrostatics. Which of the following shows the electric field around a point charge? Definitely not that one, because this would be if I had a positive and a negative. That's the butterfly. We know this is garbage. B's not right around a point charge. They're trying to get you to confuse this with magnetic fields around a wire. And I've taught you pouter nin. It has to be A. Give one way of giving a plastic rod a static charge. If you were to write in here, just rub it, you're going to get a loser mark. We've got to rub it with an insulator. So we could say charging by friction or rub the rod with an insulator. That is a cloth. A cleaning company uses an electric spray to produce a cloud of disinfectant inside the bus. They give the spray a negative charge to each droplet. It then says the droplets have a negative charge because, and I keep saying to you, the only one we can move is electrons. So it's negative because we've added electrons. Next one, we've got two shapes of clouds. So we've got this one here where it's wide and spread out. This must be where they've all got the same charge. And we've got cloud from sprayer 2. This must be with no charge. So sprayer 1 gives a negative charge. That makes sense. Their droplets have repelled to give a bigger area. No charge. Okay, so now we can explain that. This makes sense. Explain the difference in shape of the two clouds. Spray 1 is wider or more dispersed or spread out, anything for that for the mark. And it's because the droplets all have the same charge, so they repel. On to the next part. We've now got a cloud of disinfectant containing charged droplets is towards the seat in a bus, so we know that this is at 0 volts. Explain how charging the droplets makes sure that every part of the seat. So ultimately we're going to have, whereas with a normal spray it'll just go in the direction that you spray it, on this one it'll be able to go around the back because we'll induce a charge as we spray this. These negatives will induce charges on the front of the seat, causing them to attract. So kind of handy. Charged droplets sounds pretty good to me. So here we go. Oppositely charged droplets will be attracted to the seat, so you can see that key word. We're going to have non-dribbling down here. Most of this disinfectant is going to go, pretty much all of it will go onto that seat. But the other part is it'll also attract to all the surfaces, so we'll actually get spray going in all directions and attracted to the back. Now the mark was just for saying anything around, and it'll go around the back, not just the front. Okay, lovely 6 marker for this. This would be lovely if this came up. Figure 18 shows an aeroplane being refueled. The fuel passes through the pipe into the fuel tanks in the wings. The fuel is very flammable. A build-up of static charge. So as this plane's in the air and insulated, flying around, electrons are going to build up on here. If they then attach this lovely pipe to it, they'll get a spark. Boom, he's dead. Anyone in the plane's dead. So it says, explain why the build-up of static charge would be dangerous. So the idea that it'll create a spark as it discharges. And how can the danger be reduced? Before this person attaches that, they attach a cable to discharge the electrons to the ground. So here's your model answer. A build-up of electrons or charge could discharge and cause a spark. Next part, this could set the flammable fuel on fire or blow up the plane. To prevent this, you need to discharge the plane before refueling. Now we're going to talk about having a conductor that will take the electrons to the ground. So we can attach an earth wire from the plane to the ground. This transfers electrons from the plane to the ground. The plane now has no potential difference, so no risk of a spark. So that's your model answer for 6, and that's quite a nice one for a 6 marker.